All right, I got a Cobra 139 XLR on my bench here, and this is my own radio. I got this a while back in a lot of radios. I think it was like, I don't know, something like 10, 12 radios. I forget, but I purposely got the lot for this bass. I love the D858 sideband chassis, as you guys know. Probably, it's a very close second to the Telsat SSB 140 and you know anything really with that chassis. This is a close second for me, and you know in fact might even kind of be tied for first. But yeah, I own several of these. I actually have a couple of the Robins. I have, what's that over there? That's a Stalker 202 from T-Berry. I have this one. Yeah, I love them. I love working on them. They make sense to me as a tech. And yeah, just really great performing radios. But there is one downfall here to the Cobra 139 XLRs, and that is a resistor and a transistor. And it's right in the area of the sideband crystals, and it just makes this very difficult to align and to use, actually. It drifts so much, and there's actually a service bulletin that's supposed to be done to these whenever they came in for service, and it was supposed to be done, but I'm sure many of these 139s never saw, you know, warranty work or whatever, and you know, this kind of just got left behind. And what you'll find is in later models like the Robin and the anything really, I know the president even changed over. In fact, I've never actually seen a president with President Washington with this problem. It's always been the Cobras. And yeah, even my T-Berry I have. So let me explain before I go any farther. So I originally was not going to do a video on this. So that's why I'm kind of like, you're catching me here, like kind of starting this. But what it is this. So you have, anybody who has any, like even a 138 or whatever, knows that this plate right here gets extremely hot, like lava hot. And that's for two reasons. In the case of this 139 transistor, what is this, T36, transistor 36, normally lives here. And that's only half the issue. The other half is this resistor here that gets super hot. So what that does is it kind of acts like an oven, if you will, for this whole area here. And it creates very bad drift. Because you have the three crystals right there. Not only is it tough to align, but even just using it, it just makes for a bad day. So Cobra actually came out with a service bulletin, and that's to relocate the transistor and eliminate what is this, R151, I think it is. Don't quote me on that, but I think that's what it is. You know, they put this silly wrap around it as if that's going to help. And it doesn't, obviously. So, if you look over here, you can go about this a few different ways. So, back in the day, Cobra, they would supply you with a special heat sink and whatnot. And, you know, instructions on what to do. This is basically what the service bulletin is, minus the actual like service parts. So if you look over here at the Robin, transistor 36 is mounted right there. Makes sense. You know, just it is what it is. And you can see actually the wires coming out of that transistor come over here, the yellow It's right there where normally that resistor would be. And then this gray wire is where the transistor would normally be. And then the green wire comes over here. So we're going to do something similar. So again, you can go about this a few different ways. So if you have a parts chassis, you can go ahead and do it like this. This plate is a direct bolt in for this. It's the same bolt pattern. It's just 2 screws. It's just that this plate is longer, obviously. So you can go ahead and do that. Put that in there. Mount this transistor on that plate. Call it a day. Wire it up. You can see I didn't do that here. But this is way better. There is nothing here heating up these crystals. So now, how do you actually do it? So what I did was, in the past, when I've come across one that hasn't been done yet, I've put TR36 right here, right on that, and it's worked well. There's enough surface area there to dissipate the heat. I think I've never put it on there, but I think that putting it on here, there's just too little of a heat sink to dissipate that heat that these transistors put out. So this is the first time that I've done this. So I actually took a heatsink from a Cobra 29 XLR, and as you can see, I mounted TR20 transistor. Was it 26 or 36? Whatever it is. I think it's this TR36. And I've mounted it on that. And if you look on the back, it actually looks like I used the proper screws. But if you look in the back, it actually looks like it belongs there. You know, it doesn't look bad. So what I did was I just drilled 2 holes, nice and straight. I took measurements, you know, and then I mounted this right to the actual frame, or the back cover, whatever you want to call this. And I put thermal paste in between this aluminum heatsink and the actual back cover. And yeah, so that's how I decided to mount this. I think it's going to work well. You know, I don't see it, because what's going to happen is, too, this is going to this will probably do half of the heat dissipation, and then the other half is going to get absorbed into the back cover. And of course, there's thermal paste, and you know, you got to make sure you mount these right. You know, there's a mica film behind there, insulator, and that's a plastic or nylon screw. You can, you know, if you want, you can do it the way that, you know, the other ones are done. You can have a ceramic insulator. You just have to have something insulating it. That's all. However you do it is up to you. So now, what's going to happen is we're going to run these kind of the same way Robin and the rest of them did theirs, except for one difference. Well, if you look over here, the wire is already taken up that spot there. This green wire, the green wire that's normally on the Robin there, Cobra already has a wire in that spot. So anyway, that's why it's going to be done a little bit differently. But we're going to take this resistor out, and then we're going to run one of the leads to that. We're going to run one of the leads to the other side, and then we're going to run one wire right through and then solder that to the back side of the board, and then eliminate that resistor altogether. That's how it's done. Nice and easy. And then when you go to align this, if anybody has tried to align these, they can be a real pain in the butt to align. You know, you can sit here for an hour, let this thing warm up, and it'll still drift. It's just a real pain. And then obviously, you know, using it, you know, it's another issue. And you can never get this aligned. I couldn't anyway. the Robin and everything else, man, those things align perfectly. These Cobra 39 XLRs do not want to align. It seems like you'd have to let that thing heat soak for like a day before it starts to stabilize. But anyway, that's besides the point. Let me get this wired up, and then we can go ahead and yeah, that's really it. I'll take that out and we can go ahead and see how it looks. All right, stand by. All right, well, here's the finished product. I chose to take out the resistor. You can do it a couple of different ways. So you can do it the way I did it. So you take the resistor out and then put the black, which is the black is the collector. You can put it right where that resistor used to be. And then the orange, which is the emitter, basically you're just replacing the legs. The easiest way to put it is the legs of the transistor. You're just basically extending them out with wires. Right, so you have the base, collector, emitter. So in this case, the base is yellow, the collector is black, and the emitter is the orange. Okay? You could do it two different ways. So you can just run all three wires in through the hole where the where the transistor used to be, and just hook up the wires as if you're just extending the transistor terminals. And then you can leave the resistor in there, but then you can just clip the top of it. Or you can do it the way I did it here. I took the resistor out. All right, that's where it would normally go. Just connect the collector to there. And then the base and the emitter. That's basically how I did it. If you look on the other side. Where am I here? There you go. So the yellow there just gets soldered on the other side. And then the red, as if you see it here, well, not the red, the orange. It's the same thing. I just put it through that hole. Basically doing the same thing as this. Where that gray wire is, it's essentially the same. You're doing the same thing. So however you want to do it. Both ways work just fine. Me personally, I hate leaving cut components, as you guys know, inside a radio. So I chose to take it out. Now this is going to build up a little bit more heat, so that's why you need a better heat sink. But this is still cool to the touch. And then I just wrote TR36 there, just because. And that's it. Nice and easy. So now you no longer have, you're not going to have any more frequency drift, because not only did you eliminate TR36, which puts out a little bit of heat, but you also eliminated that resistor, our, what is it, 153, which was probably producing 80% of the heat around there. Yeah, so I've been restoring this thing as well, bringing it back. So this thing had a horrible, horrible, horrible channel mod. When I first plugged this thing in, it was receiving, not transmitting. It had no AM power, no AM receive, I believe. And yeah, I found this mess under there. I didn't even notice there was a switch here somebody had put on the bottom. CBRC, I'm assuming that's to get the alpha channels. But whatever happened there, it just wasn't working. So I just reversed all those stupid mods. So it wasn't too bad. The PLL area there, I got it back together, and it's transmitting fine. It needs an alignment. It's way too much on sideband. But also C179, which is a tantalum. This here can give you problems too with transmit, especially on AM. Yeah, and also make the transmit relay chatter. So if you have that happening to your radio, chances are this C179 could be your issue. And in my case, this was the AM regulator, which the reason why I wasn't getting AM transmit was because of this bad. These, from the factory, they have issues, not because these transistors are bad, but because they didn't tighten them up enough. And that was one of the problems with a lot of these radios. You know, it's not the transistor that's crap, it's the lack of thermal pastes that came from the factory, and the fact that they weren't screwed tight enough to the heat sinks. Yeah, so it's make sure that everything is screwed in. You don't have to go cranking these things down, you know, just make sure it's snug, and when you put your thermal paste on, that it kind of oozes out a little bit on the side. You know, it's not a birthday cake, so don't go decorating it, you know, like a birthday cake and having everything just, you know, you see it sometimes, it's just oozed out all the way around. That's unnecessary. You know, that's the regulator I changed out. That's what you need. No more than that. It's plenty. All right. Yeah, so that's it. So this radio is, I can now proceed and do my recap and alignment. I don't have time for that today, but eventually I'll get to it. So what I do is all my own personal radios, I take notes. I keep like a little folder with all my the work I've done to the radios. So that way when I go back to my notes, I know what's been done, what hasn't been done, you know. So at a later date, I'll recap this and align it, and yeah, put it up on the shelf. It's a radio I'm keeping. I've been cleaning out a lot of my radios, so I've been trying to go through them, see if it's, you know, see if they're worth fixing. If they're not worth fixing, sell them for parts or whatever. But this one here ended up being okay. It needs a little cleaning, but it's a good looking radio. But anyway, I thought I'd document this this process just in case, you know, if you guys have I'm assuming a lot of these 139 XLRs went through without having this done. I'm just going to go ahead and assume that. So if you have one at home and, you know, you see it hasn't been done, you should really do it. It's going to make your life a lot better if you're talking on sideband especially. And yeah, that's basically it. And as you know, as far as alignment goes, it makes it a hell of a lot easier to align. You know, you turn this thing on for an hour or so, let it get warm, and then your alignment's going to be rock steady. You know, you're not going to be chasing, you know, these trimmer caps, you know, for 2 hours trying to get these frequencies to stabilize. You know, now you can, you know, there's nothing here to heat this up. You know. Alright guys, thanks for watching. Hopefully you learned something. And if you can't do this yourself, which I understand, you know, I don't know if I said it previously, but this is just a heatsink off of a Cobra 29 XLR. You can get universal heatsinks. You can make your own. Like I said before, you can even take one out of a donor radio, whatever you want to do. But you definitely have to put this on a heatsink, you know, because it is going to produce a little bit more heat. But yeah, so that's about it. But if you don't feel comfortable doing this, just send it out to your local tech, or, you know, whoever you use to repair your radios. It's worth doing. You know, even if they charge you, I don't know, whatever, 50, 100 bucks, you know, it's worth doing. You know, I don't know what they'll charge you. I'm just saying, you know, it's worth, this is worth doing. This is a really, really good upgrade to these radios. All right, guys. Thanks for watching. I'm done. All right, so we can actually look at the difference between the 139 and, say, the 520D. So I have both manuals open, both Sam's manuals. So this is the Robin, and this is the Cobra. So we can actually look here. There's a typo here. So this is TR36, and that's a resistor. It's supposed to be on the board anyway. It's written R153. So this is a typo. If you use Sam's manuals, you know that there's a lot of typos. But anyway, you can see here that R157 or 153 at TR36, the collector voltage, you're going to see 9.97 volts. So, you know, that's what the resistor is bringing that down to. When you look at the Robin, you can see that R157 or 153 is not there, but you're getting a collector voltage of 13.77. So this is going to run a little bit harder, obviously. So that's why it's important to give it a better heat sink. So, you know, you just can't, in the case of this 139, you can't just eliminate that resistor without, you know, having, well, I mean, you would want to relocate that transistor anyway for heat purposes. But, you know, the majority of the heat's coming from that, from this resistor. But, yeah, that's the reason why you have to relocate TR36 and put a better heat sink and make sure that, you know, it's dissipating all that heat, that thermal heat better. So, yeah, I just wanted to show that so you can see the difference between, you know, how Robin and subsequently, you know, later models, you know, did that circuit, you know, versus Cobra. So yeah, that's, you can see there the difference. 56, is this a 56? Let me see here, if this is even right. I can't even, yes, it is, okay, yeah. All right, just wanted to add that on.